Hi friends, welcome back. In part 6 of solving Neet, JEE and JAM examination questions. In this video, the questions which will be discussed will be based on the topics of amino acids, acidic strength of carboxylic acid, basic character of amines, ozonolysis, basic character of heterocyclic nitrogenous compound, and preparation of phthalimide. So let us start with the first question. The increasing order of the pKa of the following amino acid in aqueous solution is, and the 4 amino acid which are given is glycine, aspartic acid, lysine and arginine. Now, what we must understand is, what do we mean by pKa? We have discussed in our previous video also, what do we mean by pH and pKa. For those who don't know what pKa is, please watch the previous video on relative strength of acid and bases, the pH and pKa concept, so that you become clear that what do you understand by pKa, so that solving of such questions become easy. Now, one point which we must understand about pKa is the pKa value is inversely proportional to the acidic strength. That means lower the value of pKa, higher is the acidic strength of a particular compound. Or in other words, higher the value of pKa, higher is the basic strength. Now, the 4 options are given. Now, what we must understand in such type of question is the structure of the amino acid. So, you must know the structure of all the amino acids. So, if you see the 4 structures of amino acids which are given: glycine, aspartic acid, lysine and arginine. Now, if you see glycine has the equal number of carboxylic acid group and an amine group, NH2 group. Over there it's written as NH3 plus and COO minus because it is in Zwitter ion formation. But NH3 plus we can say it as NH2 and COO minus we can call it as COOH. Aspartic acid, you can clearly see there is 2 carboxylic acid group and 1 amine group. Lysine, you have 2 amine group and carboxylic group, and finally the arginine. Now, amino acids are classified into 3 categories based on the number of the carboxylic group and the amine group which are present in the molecule as acidic, basic and neutral. If you have equal number of amine and carboxylic acid group, we call it neutral. If it is carboxylic acid group and amine, if more number of carboxylic acid group is present and less number of amine, then we call it acidic. And if more number of amine group is present and less number of carboxylic acid group, then we call it basic. Now, if you can see the arginine and lysine, you can clearly see that there is more number of amine group than carboxylic acid group, so they are basic. Aspartic acid has more number of carboxylic acid group than amine group, then basically it is acidic. And glycine has equal number of carboxylic acid group and an amine, so it is neutral. Now, comparing with lysine and arginine, arginine has more number of basic group, as a result of which arginine becomes the most basic or having the highest value of pKa. Then comes lysine, then comes the neutral, that is glycine, and finally the aspartic acid, which is acidic and have the lowest value of pKa. So if I try to arrange this, aspartic acid will be lowest, then comes glycine, then comes lysine, then finally comes the arginine, which is having the highest value of pKa or the lowest acidic strength or the highest basic strength. So that is how we need to solve such problems. Let us come into the next question. The correct order of or decreasing order of acidic strength is, so they have given us carboxylic acid, aliphatic carboxylic acid, and if you see the groups which are present, you can clearly see in the options that the groups are electron withdrawing group. So these groups will be showing -I effect, negative inductive effect. Now the question is, what is the relationship between -I effect or electron withdrawing group and that of the acidic strength of carboxylic acid? So if we try to understand that, the acidic strength of a given compound is decided on the basis of -I effect on the substituent of carboxylic acid. higher the value of minus I effect, or higher the minus I effect of a substituent, higher will be the acidic strength. Very important. If the group which is attached to a particular carboxylic acid is highly electron withdrawing, then the compound tends to become more acidic. So if the value of minus I effect is, or the higher the value of minus I effect, higher will be the acidic strength. So if you try to see the groups which are present, the order of their minus I effect is nitro first, then comes cyanide, then fluorine, and then cyanide. So similarly, the order of decreasing acidic strength will be, first nitro will be the highest because it is the most electron withdrawing or having higher minus I effect, then comes cyanide, then comes fluorine, and then finally chlorine. So that is how we understand the relationship between minus I effect or electron withdrawing substituent and that of acidic strength of carboxylic acid. Let us move into the next. Arrange the following amines in the order of their decreasing order of basicity. So they have given this, and we have to arrange them in decreasing order of basicity. So the options given are this. Now, first, let us try to know what are these different amines or heterocyclic nitrogen compounds. It is piperidine, pyridine, and pyrrole. Now we can clearly see the lone pairs, okay, and what kind of basic character we are talking about, or what kind of base they are, is nothing but they are Lewis base which can donate the pair of electron. So remember that all of these three are Lewis bases. So their basicity depends on how easily they can donate the electron. Now, easierly they can donate the electron, more basic they are. If they cannot donate the electron easily, then less basic. If they cannot donate, least basic. That is how we can understand it. Now, if you try to see the structure of these three compounds, you can clearly see in pyrrole, the last one, the lone pair is involved in resonating actually, or in resonance with the pi bonds. So the lone pair will not be free to be donated to other molecules. Pyrrole is the least basic as the lone pair is not free for donation as it is involved in resonance. Okay, since the lone pair will be involved in resonance, you can easily draw the resonating structures. So if the lone pair is involved, obviously lone pair will not be available. If it will not be available, hence it will not be donated easily. So it will be the least basic. Piperidine is the most basic as the lone pair is in sp3 hybridized orbital, while in pyridine it is in sp2 hybridized orbital. Now try to understand, if you see pyridine and piperidine, the difference is the nitrogen in pyridine is sp2 hybridized and the nitrogen in piperidine is nothing but sp3 hybridized. And remember that even in pyridine you can see the conjugated double bond, but the lone pair is not involved in resonating structures or in resonance. Okay, the lone pair does not take part in resonance. Okay, it is not taking part in resonance. Only the pi electrons take part in resonance in case of pyridine, though it has the lone pair also. Now, both of them has lone pair on nitrogen atom and both are not taking part in resonance. But the only difference between pyridine and pyridine is pyridine nitrogen is double bonded and it is sp2 hybridized. Your pyridine nitrogen is single bonded and is sp3 hybridized. Now, what we know is greater the S character, more strongly it will be bonded and less available for donation. Always remember that. And sp2 hybridized orbital, we know that they have greater S character, that is nearly of 33.33%, and while for sp3 hybridized orbitals they have nearly to 25% of S character, so the S character will be less, and if S character will be less, then it will be less tightly held. Okay, so as a result of which it will be more available for bonding. So the piperidine will be the most basic. That is how we can understand. Let us move into the next. The major product of the following reaction is, so they have given reaction where you can see clearly the reaction given, and the option given are this. So basically we need to complete this reaction. So what we need to understand is it's a reaction of carboxylic acid with ammonia. So ammonia being a base and carboxylic acid being acidic, so it's basically an acid-base reaction. So let us try to see the reaction. So the compound given to us is phthalic acid, which reacts with ammonia. As I have told you, phthalic acid, an acid, ammonia a base, so it will give you ammonium phthalate. That's the salt which forms. That phthalic ammonium phthalate, when heated, gives you phthalimide, which you can clearly see. It loses 2 molecules of water on heating it. Then the phthalimide on strong heating gives you phthalimide. Okay, so our answer is phthalimide, which you can easily see in the option given. Our next question is, the correct order of the basic strength of methyl substituted amine in aqueous solution is? So these are the three. Now, to understand the basic strength of methyl substituted amines, we must know some of the points, and they are the basic or the basicity of amine in aqueous solution. Remember that in aqueous solution primarily depends upon the stability of ammonium cation formed by accepting a proton from water. Okay, as you know that amines are basic. Okay, so what they do is they easily accept the H plus from water. The more easily they can accept the H plus from water, that is aqueous solution, the more basic they are. If they cannot accept H plus from water, a proton from water, then they are less basic. That is how we decide the basicity of amine. The stability of ammonium cation. Now once it takes the H plus, it turns into ammonium cation. Now the stability of ammonium cation in turn depends upon a combination of 3 factors. So it depends upon the stability of that ammonium cation which is formed after accepting a proton from water, decides whether the amine will be basic or less basic or the least basic. So those 3 factors are plus I effect of the alkyl group. Okay, how much electron donating the alkyl group is, extent of hydrogen bonding with water molecule. Okay, that is what we call as solvation also, and steric effect of the alkyl group, how bulky your alkyl group are, how big your alkyl group are. So these are the 3 factors which decide it. So if I try to see these 3 factors and go for a conclusion, tertiary amines are the least basic due to steric hindrance. Okay, in case of tertiary amine, the steric hindrance is very high, so they become least basic. Secondary amine are more basic due to plus I effect of the 2CH3 group. I hope you can understand that a secondary amine will have 2CH3 group, methyl substituted amine, so it will have 2CH3 group as compared to 1 CH3 group in primary amine. Okay, so the secondary amine will be the most basic, then the primary, and the least will be tertiary. So secondary, then primary, and finally comes tertiary. Let us move into the next. Enzyme that utilize ATP in phosphate transfer require an alkaline earth metal M as the cofactor. M is, and the option given are this. Now this particular topic we have discussed in very much detail in one of the videos uploaded recently, that is on glycolysis. So please watch that video. We have explained each and every reaction properly, what is happening in glycolysis. So in that we have discussed this phosphate transfer, and in that I have explained that in case of phosphate transfer we require one cofactor, that is an alkaline earth metal, and that is nothing but the option 2, magnesium. So please watch that video on glycolysis which is uploaded in this particular channel. Let us move into the next. An alkene A on reaction with O3 and zinc H2O gives propanone and ethanol in equimolar ratio. Addition of HCl to alkene A gives B as the major product. The structure of B is. So they have given 4 options. So these are the 4 structures. We have to find the correct one. Now we must understand what reaction it is. So if you see the question, alkene is reacting with ozone. That is nothing but ozonolysis. Now once that alkene reacts with ozone, it gives you propanol and ethanol. That actually we do in class 12 as the preparation of preparation of aldehyde and ketones also. Once that we find the structure of that alkene, what we need to do is react it with HCl to give you a major product, and that major product will be one of these 4. So let us try to see the reaction to be clear. So an alkene A, that should be the structure of the alkene. It reacts with ozone in presence of zinc and water. That is ozonolysis, gives you ethanol and propanol. Now a very simple trick to find out the alkene in such questions is, first you write the structure of ethanol and propanol which is given. You can clearly see the carbon groups which are present in ethanol and propanol. In case of propanol you have C and 2 CH3. In case of ethanol you have CH3. You can see in structure A, one side of, or the left side of A has one CH3 and one H which is present in ethanol, and the right side of A you can clearly see it is the same group which you have in propanol. So that is what we have to do. Whenever they give you the product in such cases in ozonolysis, always take the group of the product, like ethanol CH3, okay, and H. If I leave the carbonyl group CO, if I leave in ethanol, what I'll have is CH3 and H. So that is on the left side. In case of propanol, I have CH3 as the group. If I leave the carbonyl group CO, so that is what actually is in the right side of A. So that is the easiest way to do such type of question, particularly ozonolysis. So what I have got is A. Now what they have told is that A reacts with HCl to give you a major product. Now if you see A is an unsymmetrical alkene. If you pass a plane through the double bond, the two groups or the two sides, if you see, they are not same. That is what we call as unsymmetrical alkene. And when unsymmetrical alkene reacts with an unsymmetrical reagent like HCl, HBr, then a Markovnikov addition takes place, what we know. So in Markovnikov addition you get two product, one major and minor, depending upon where your negative groups attaches. Now what we need to apply is Markovnikov rule, and according to Markovnikov rule, the negative part of the adding molecule or addendum, that is in this case is HCl, and the negative part is Cl, the negative part must go to that doubly bonded carbon atom, that double bonded carbon atom which has less number of hydrogen atom. So if you see the molecule A, the right carbon, okay, the double bonded carbon, the right one has less number of hydrogen atom and the left one has one hydrogen atom. So the Cl should go to less number of hydrogen atom. So the less number, or the carbon which containing less number of hydrogen atom, that is the right carbon of A. So it will go, Cl will go to the right carbon and H will go to the left carbon. So that is your structure, that is your B, and if you compare, you'll get your answers. So that is how we need to solve this type of questions. So that is all about this particular video. Do watch the various other parts of solving Neet, JEE and JAM examination questions which have been already uploaded in the channel. Do subscribe for this channel for explanation on various topic in chemistry. Thank you everyone.